Okay, we are in section 6.4 and we're getting ready to work problem 2, and we're dealing with logarithms, and we are actually graphing logarithms and talking about their domains and ranges. This is the basic log. When there's no base written here, the base is understood to be a 10. So this is log base 10 of x. It looks like this. This is what I put in. This point is 1, 0. It's sort of like an anchored point. It's an important point. Generally speaking, just like with the exponent, if you plug in 0 for an x and an exponential, you're always going to get 1. So with the logarithm, when you plug in the 1, your answer there should always be 0. Keep in mind that exponentials and logarithms are inverses of each other. So we have a vertical asymptote here, and then the kind of reddish line is the actual graph of the logarithm. And this point right here is the point 1, 0. Your domain here is from 0 to infinity. Where the asymptote is, technically there's no values there. It gets closer and closer, but not there. The range, this keeps going. Even right here, it keeps going as far as the y is concerned. So the range is all real numbers, negative infinity to positive infinity. The equation of this line right here is x equals 0. It's actually the y-axis, but the equation of the y-axis is x equals 0. That's just kind of the basics for the graph of a logarithm, its domain, range, and asymptote. Now, the problem you have is a logarithm, but has a little bit more here. So this -4, just like any other transformations that we have, are going to shift our graph 4 units to the right, and this -5 is going to shift it down 5 units. So it's going to be 4 right and 5 down. So let's see, what does that actually affect? Well, if you go to the right 4, that changes the domain. Whatever is inside right here, and I've taken this and kind of worked it here, x minus 4 has to be greater than 0. Whatever you're finding the logarithm of has to be greater than 0. So x has to be greater than 4. So your domain ends up being 4 to infinity. Then they want you to graph it, and I did go ahead and graph in with Desmos and talking about it here. That I think it's a multiple choice, and I think on that one it was B. As we said, you would shift the graph 4 units to the right and 5 up. So the point that we started out with, that we had on our graph, that was 0, that was 1, 0. It was 1, 0. So if I add 1, what's the transformation? If I'm at 1 and I go right 4, I'm at 5. If I am at 0 and I go down 5, I'm at -5. So we went from the point 0, I always say this backwards, we went from the point up here that was 1, 0, we went to the point 5, -5. 1, 0. 1, add 4, puts you at 5. 0, subtract 5, -5. So this is the graph. So it moved, the vertical asymptote moves the 4 units, but the up and down shift, yes, it does shift, but it doesn't change the domain. So you went right 4, down 5, your answer choice is B. Now the range. The range was all real numbers before you started. The range is still going to be all real numbers. If it's all real numbers, any transformation will keep it that. Can't change that. The vertical asymptote started out at x equals 0, but since you had a shift to the right 4, it becomes x equals 4. Now, they ask you to find the inverse of it. Well, the inverse of a logarithm is going to be an exponential. You'll go through the same basic 4 steps that you go through to find any inverse. F of x is equal to log x minus 4 minus 5. Your first step is to replace f of x with y. Did that. Then you interchange the x and the y. Okay, now your objective is to get it solved for y. Well, the first thing is going to take this -5, put it on the other side, becomes +5. To get rid of the logarithm, you have to change it to an exponential. The understood base, as we talked about in the beginning, was 10. So the base is 10, the other side is the exponent, the opposite side. 10 to the x plus 5 equals y minus 4. 10, go around to pick up the other side and then come back to equal that. Since you've got a -4 with your y, you still want to move it. It becomes a +4. Just like previously, you replace that y with the function notation f inverse of x, and that's what it equals. Now they'll ask you about the domain and the range and ask you to graph it and that kind of thing. Remember, your range of the logarithm was all real numbers. So your domain of the exponential, for more reasons than one, because all exponentials are all real numbers, is still all real numbers, -infinity to +infinity. Remember, the domain on the original was 4 to infinity, so that's what's going to happen here is going to be the range will be the 4 to infinity, because you, of course, shifted the basic graph. You shifted the basic graph of 10 to the x. You've shifted it around a little bit. You've shifted it up 4. So this is kind of what you've got. You sort of had a point that was 5, -5 on the other one. So this one's going to be -5, 5. It's sort of the same point that started out being 1, 0, and then you've taken the inverse and so forth from there. One of the things that I like to do with logarithms and exponentials is for you to see them on the same coordinate plane with everything graphed out. This was the original log right here. This is its vertical asymptote. This is its inverse, the exponential. This is that horizontal asymptote. This is the line y equals x, and the graphs are symmetric to that. And this to the line and that to the line should be the same distance, and all of that. They are symmetric. It's kind of interesting to see how they mirror across that line. I believe that's the entire problem.